In the previous movie, we created twistable arm segments for our result arm joint chain using IK splines. In this movie, we'll add the ability to squash and stretch both the IK and FK arms. Start by opening the file Character Rigging, Part 23 Start, or by using your own file from the previous lesson. This will largely be a review of the same techniques we introduced in Part 5 when adding squash and stretch to the spine rig, and adapted in Part 13 and 14 for the leg rig. Like any other part of the body, the ability to squash and stretch is important, not only to be able to meet certain pose demands, but also to add exaggeration and dramatic effect to specific movements. Let's begin with the FK joints, which are more straightforward to deal with than the IK joints. First, let's add all the result joints and segmented joints to the result layer so we don't select them accidentally. Now add a length attribute to both the upper arm and forearm FK joints. Remember to set them each with a minimum value of 0 and a default value of 1. Now open the set-driven key window. Load the left upper arm FK joint as the driver and the left forearm FK joint as the driven. Set a key between the upper arm's length attribute and the forearm's translate X attribute at its current value. Then set the upper arm's length to 0 and the forearm's translate X attribute to 0 and set another key. You'll notice that the geometry behaves a little strangely, but we'll take care of that in a moment. Now using the graph editor, set the forearm's translate X animation curve's tangent to linear and its post-infinity interpolation to linear. The upper arm can now stretch infinitely. Repeat this for the left forearm FK joint by creating a new length attribute to drive the left hand FK joint's translate X attribute. Next, we need the geometry to scale accordingly. Because the method we use to create the segmented arm sections is so similar to the method we use to create the torso, we'll stretch and squash them the exact same way. To review, we'll use curve info nodes to track the length of the upper arm and forearm joints via their respective IK spline curves, then scale the result joints according to that length. Select the left upper arm result joint and its corresponding segmented joints and curve shape node, and open the node editor. Show the connections. Create a curve info node and rename it left upper arm info. Also, create a multiply divide node and rename it left upper arm normalized div. Feed the world space attribute of the left upper arm curve into the left upper arm info node's input curve. Now feed the output of that node into the left upper arm normalized div node you created and divide that value by the hard at rest value. Then connect the output of the normalization node into each of the upper arm result joints' scale X attribute. Once you're done, check to make sure the upper arm geometry stretches along with the FK joint. Repeat the process for the forearm. Just like before, we'll leave the last joint in the chain alone, since scaling it wouldn't serve any purpose. With the FK stretch fully working, we can turn our attention to the IK stretch. Reviewing our work on the leg, you'll recall we used a distance node to figure out the leg's maximum extension length, then use that distance value to set driven keys for the IK leg joint's translate X attribute via the script editor. We'll do the exact same thing here. First, notice we don't actually have an IK handle driving the IK arm yet, so we'll have to create one. Before setting up the IK handle, notice how our arm joints are perfectly straight. In order to help Maya figure out which way to bend the forearm joint during an inverse kinematic calculation, we should set a preferred angle on the forearm joint with a slight bend. This wasn't necessary for the leg because there was already a natural bend to the joint structure. Rotate the IK forearm forward about 5 to 10 degrees in the y-axis. This will be our preferred bend direction. Go to Skeleton, Set Preferred Angle. Zero out the rotations to go back to the bind pose. Now create an IK handle by selecting the Skeleton IK Handle tool. Make sure the current solver is set to IK-RP solver, then in the outliner, control-click the left upper arm IK joint and the left hand IK joint. Rename the handle and effector to left arm handle and left arm EFF respectively. Create a second IK handle, this time with an IKSC solver, from the IK hand to hand end joint, and rename their handle and effector similarly. Parent both these IK handles under the left arm control. Now if you move the IK arm control, the forearm bends as you'd expect, and the hand joint aligns itself with the arm control. This matches the leg-foot alignment we set up in part 13. Next, notice that unlike the foot control, our arm control translation is not frozen in the bind position. This is because, unlike the legs, the arms don't have a natural default position. As such, we've left the zeroed position at the origin. However, we'll still want to preserve this bind position for future use, so we're going to save it as a preset. Open the attribute editor and select Presets, Save Transform Preset. Save this as left arm IK control bind. Now if you move the arm control elsewhere in the scene, you can always return to the presets and return it to the bind position. We're ready to tackle the joint stretch. First, use the Create Measure Tools Distance Tool command to create a distance node and point snap its start and end locators to the left arm start bind joint and left arm end bind joint respectively. Rename the nodes left arm IK length start loc, left arm IK length end loc, and left arm IK length respectively. Parent the left arm IK length end loc under the left arm control. Now, as with the leg before, we know the length of the upper arm is represented by the translate X attribute value of the forearm joint, and that the length of the forearm is represented by that of the hand joint. Thus, their maximum length without any stretching is the sum of those two values. We'll set a driven key for when the length of the arm is equal to this sum, and another for when it's 2 times that value. To do that, we'll use a slightly modified version of the script we used in Part 13. You can find this script bundled with the scene files linked below. Once you run the script, Maya creates the necessary driven keys to allow the IK arm to stretch up to 2 times its normal length. Since we want to extrapolate this effect to infinity, select the 2 IK arm joints and open the graph editor. Set each curve's tangent to linear, and its post-infinity to linear as well. By now you should be getting pretty good at implementing squash and stretch on different types of joint chains. Understanding the intricacies of this process is a valuable asset to have as you create new rigs. In the next movie, we'll create an elbow control for this arm and give the IK arm the ability to snap to it.